All right, let's dive into one of the most incredible, most complex systems you can possibly imagine, your immune system. Seriously, it's like a microscopic army inside you, fighting nonstop 24/7 just to keep you healthy.
I mean, just think about that. Every single day, you're getting bombarded by bacteria, viruses, all sorts of nasty stuff. So how is it that you win all these little battles most of the time without even realizing a fight is going on? Well, it's all thanks to this amazing, highly coordinated defense network. You can basically break the whole system down into two main teams. First up, you've got your innate immunity. Think of this as your general security force. It's always on patrol, ready to attack anything that looks foreign. It's fast, but it's not very specific. Then you've got your acquired immunity. Now, these are the special forces. They take a little longer to get going, but they learn to recognize very specific enemies, and they never, ever forget them. Okay, so where does it all start? Well, before any invader can even cause trouble inside your body, it first has to get past the outer walls of your fortress. And this is your simplest, but maybe most important line of defense. Your skin is the big, obvious one, right? It's a tough physical barrier. But you've also got mucous membranes lining your nose and your airways, literally trapping invaders in this sticky goo. Even your tears and your saliva are part of the defense team. They've got an enzyme called lysozyme that just makes bacterial cells explode. And of course, anything you swallow has to survive the intense acid bath that is your stomach. Not many things can. But, sometimes things get through. A little cut on your finger, for example. And when that happens, that's the signal for the general guards, the first responders of your innate immune system, to hit the ground running. And there are a few key players you should meet. First, you have the neutrophils. These guys are the foot soldiers. They're the most common type of white blood cell, and they absolutely swarm the site of an infection. Then there are macrophages. I like to think of them as the heavy-duty cleanup crew. They gobble up invaders, but also any dead cells and debris lying around. And then you have natural killer cells, or NK cells. They have a really unique job. They hunt for your own cells that have gone rogue, cells that are infected with a virus or have become cancerous. So how do these cells actually take out the bad guys? Well, a lot of them use this process called phagocytosis, which literally means cell eating. It's awesome. The cell basically sees an invader, wraps its membrane around it, pulls it inside, and then just drowns it in a cocktail of digestive enzymes. Game over for the pathogen. And you can see it happening right here. Look at that. The cell literally reaches out and swallows the microbe whole. It's not just trapping it. It is completely consuming and dismantling it from the inside out. It is just an incredibly efficient way to neutralize a threat, right then and there. But sometimes the invasion is just too big for the general guards to handle on their own, and when they get overwhelmed, they know they need to sound the alarm. It's time to call in the specialists. Now, the way they do this all comes down to something called an antigen. The easiest way to think of an antigen is like the enemy's uniform. It's a unique molecule, usually a little protein on the surface of a virus or bacteria, that your immune system can learn to spot and recognize as not from around here. And here's where it gets really clever. After a macrophage eats an invader, it doesn't just destroy all the evidence. It actually takes a piece of that antigen, a piece of the enemy's uniform, and puts it on its own surface. It becomes what we call an antigen-presenting cell. It's basically holding up a flag and shouting to the rest of the immune system, "Hey, this is what the bad guy looks like. We need the experts now." And that signal, that presented antigen, is the call to arms for the second army, your acquired immune system. This is the special ops team, the elite force that is custom trained for one specific target. This elite force is mainly made up of two kinds of cells, B cells and T cells. They're both hunting for that specific antigen, but they do it a little differently. B cells are kind of like scouts. They can spot the enemy's uniform floating around freely in your blood. T cells, though, are more like detectives. They need to have the evidence presented to them directly by one of those antigen-presenting cells we were just talking about.
And within this team, you have some serious specialists. The helper T cell is the general. Once it sees that antigen, it starts running the show, activating all the other players. Then you have the cytotoxic T cell. This is the assassin. Its job is to hunt down and kill your body's own cells that have already been infected, stopping the enemy from making copies of itself. And then the B cell, once it gets activated, transforms into a plasma cell, which is just an absolute antibody-making factory, churning out thousands of them every single second.
So what are these antibodies? They're these incredible little Y-shaped proteins, and they are custom built to lock onto one specific antigen and nothing else. Once they attach to an invader, they can either neutralize it on the spot, say by blocking a virus from getting into a cell, or they act like a bright, flashing tag, marking the invader for destruction by a macrophage.
This whole targeted response is just amazing, right? But the real superpower of your acquired immune system, the thing that truly makes it special, is its memory. It's like an intelligence unit that never, ever forgets an enemy it's faced.
See, the first time you get exposed to a new pathogen, it takes a while to get this whole special ops team trained and ready to go. We call this the primary response, and it can take 10 to 17 days to really reach full strength. And that long window, that's when you feel sick. But now, look at this. The second time you're exposed to that same exact enemy, the response is so much faster. It peaks in just 2 to 7 days. And it's not just faster, it's way, way more powerful. So powerful, in fact, that you might not even have a single symptom. Your body just wipes out the invader before it ever gets a foothold. So how on earth is that possible? Well, it's because after that first infection is cleared, your immune system creates these veteran soldiers called memory B and memory T cells. And these cells patrol your body for years, sometimes for your entire life, carrying the memory of that one specific enemy. If that bad guy ever dares to show its face again, they are ready to launch a massive, immediate counterattack.
And this right here, this whole concept of immune memory, is the beautiful, brilliant science behind how vaccines work. A vaccine gives your body a safe look at an enemy's uniform, an antigen, without making you sick. But that's all your immune system needs to run its primary response and build a huge army of those memory cells. So if the real, dangerous pathogen ever comes along, your body doesn't hesitate. It skips right to that powerful secondary response and takes care of business. It's basically a training simulation for your immune army.
It really is an elegant, powerful, and almost perfect system of defense. But, it all hinges on one critical ability: telling the difference between you and not you. Which brings up a really important question: what happens when that recognition system fails? What happens when the defenders turn on the very fortress they're supposed to be protecting?